This is a continuation of lecture 3-2, measures of variation. So remember the notation that we're going to be labeling sample mean to be x bar, population mean, mu, sample standard deviation. This is how I will abbreviate standard deviation, STDV. So sample standard deviation will be labeled as S, and population standard deviation is labeled as sigma. My next topic is Chebyshev's theorem. The Chebyshev's theorem says the proportion of values from a data set that will fall within k standard deviation of the mean will be at least 1 minus 1 over k squared, where k is a number greater than 1, not necessarily an integer. So what this just said is this. So I'll draw a picture. This is an x-axis. And I have some kind of a distribution. It really doesn't matter what I'm going to draw in here, because the idea of the Chebyshev's theorem is you don't need a particular distribution in order to work with the theorem. I will label an x bar. So this looks like it's somewhere in the middle. And what I need to label is I need to label the standard deviations, because this is how I'm going to count how data varies. So a little bit to the left is minus 1 standard deviation. Actually, they go by twos, so let me do that. Minus 2 standard deviations, plus 2 standard deviations. Let's go a little bit more. X minus 3 standard deviations, and x plus 3 standard deviations. I am on page 140 of the book. So what the theorem says is the proportion of values, so the probability that you have something within a certain number of standard deviations. So in this case, I'm actually concentrated on this 2 right here. So I'm interested in being 2 standard deviations away. So if I'm interested in being 2 standard deviations away, I am setting, for this particular example, k to be 2, because I'm interested in the probability given that I have moved 2 standard deviations away. What the theorem says is that the probability or proportion should be 1 minus 1 over k squared. Alright, well, let's see what we have here. If I set my k to be at 2, I have 1 minus 1 over 2 squared. This is 1 over 4. 1 minus 1 over 4, that's 3 over 4. Now 3 over 4 is just written as 0.75. So what the theorem says is, regardless of the distribution, if you know the standard deviation, and if you're 2 standard deviations to the left, 2 standard deviations to the right, all of this data between those two will cover about 75% of all of the data points. Now, if I continue this and look at k is equal to 3, according to my theorem, the probability has to be 1 minus 1 over k squared. So in this case, it's 1 minus 1 over 3 squared, which is 1 minus 1 over 9. And it gives me approximately 0.88, and there's 8 repeating, so I'm going to write it as 89. So if I am highlighting this one now, from here to here, I will cover about 88.89%. Now, once I found that 2 standard deviations away is about 75% of the data, and 3 standard deviations away is 88.89% of the data, you don't have to redo it again. So my first example is implementation of the direct implementation of the theorem. I am on the same page, example 3-25. The mean price of the houses in a certain neighborhood is $50,000 and a standard deviation is $10,000. Find the price range for which at least 75% of the houses will sell. So what they told me is they gave me at least 75%. As soon as I hear the word 75, I need to look right over here. Let me kind of go like this. Right over here. And according to my Chebyshev's theorem, about two standard deviations away from the mean is the range of my data that will accommodate about 75% of data points. So, if I already know this information, I know that I need 2 standard deviations from the mean. So let's read the problem again. The mean prices of housing in a certain neighborhood is $50,000. So they didn't give me, this is not a population, this is, I'm talking about a certain neighborhood, so I'll label it as X bar. And they gave it to me at $50,000. And a standard deviation is $10,000. So I'll label this as S, $10,000. Let me make it look more like an S. So if I need to be at 75%, I don't know what the distribution looks like. Doesn't matter what I'm going to draw over here. But what I have is I have my X bar, which in this case it's 50,000. What I need to do is I need to move over to plus. So in order for me to figure this out, it is 50,000 plus twice the 10,000. So I know that this number is at 70,000. Or I can move over here on the other side of the spectrum and get 50,000 minus 2 of those 10,000s. Let me move this a little bit. So what you end up with is 30,000. These are dollars if you'd like to label those over here. So I have the range between $30,000 and $70,000. At least 75% of homes of houses that will sell. Okay, let's take a look at the next example. Is on the next page is 3-26. In the next example, a survey of local companies found that the mean amount of travel allowances for a courier was $0.25 per mile. The standard deviation was $0.02, so 2 cents. Using Chebyshev's theorem, find the minimum percentage of the data values that will fall between $0.2, so 20 cents, and $0.3, so 30 cents. So this is the opposite question of the previous. So in the previous question, they gave us the number of standard deviations and they were asking for a proportion. In here, they actually give us the numbers and they ask for that proportion. So let me start labeling stuff. A survey of local companies found that the mean was 0.25. So that's what I'll write. Standard deviation was 2 cents. We do want to use Chebyshev's theorem, so I'll draw a little graph to represent some kind of a distribution. I have my x bar, which is 0.25. And what I need to do is I need to move standard deviations. So they're asking me to analyze the interval between 20 cents and 30 cents. So 20 cents and 30 cents. What I need to do is I need to label these as standard deviations. So I want to highlight this right here. I need to figure out how many standard deviations away is this. The difference between 20 and 25 is 5 cents. The standard deviation is 2 cents. If I take 0.05 divided by 0.02, I will get 2.5. This is my number K. Notice, if the standard deviation is 2, in order for me to get from 25 down to 20, I subtract 2 once, that's 23. I subtract 2 another time, that's 21. And then I need to subtract half of that 2. So that's 2.5 standard deviations. On the other side, it's the same 5. So it's plus 2.5 standard deviations. Now, very important, I found my K to be 2.5. This is step number 1, is to be able to find the K. Because the Chebyshev's theorem states 1 minus 1 over K squared will give me that proportion. So in this case, it's 1 minus 1 over 2.5. Take out your calculator, type this in. I'm missing a square, sorry. 1 minus 1 over 2.5 squared. I have 0.84. So apparently between 0.2 and 0.3, about 84% of data points. The last topic is empirical rule, and we'll take a look at that on the definition page.